Hello, my name is Mrs Kershaw and I'm one of the Science Directors with Outward Grange Academies Trust. In today's lesson we're going to look at graphene and fullerenes. Our challenge today is going to be to describe the structure of graphene and fullerenes and give examples of their uses, and our aspire is to be able to explain the properties of graphene and fullerenes and link that to their structure and bonding. First of all then, as a starter, I'd like you to draw a diagram of the bonding in graphite and what are the key features of its structure and bonding. 3 minutes. Let's self-assess this then. So, key things about graphite: it is made of carbon, it's a giant covalent structure. Each carbon atom is covalently bonded to 3 others and there is 1 delocalized electron per carbon atom. Graphite is arranged in layers that have weak forces between the layers. Graphite can conduct electricity because it has 3 delocalized electrons, and it is slippy so it can be used as a lubricant or in pencils. If you drew the diagram, you can give yourself 2 out of 3 of the marks. So what is graphene? I'll give you a hint. Look at the picture. What does it remind you of? And what does its name sound like? 30 seconds. So graphene is a single 2D layer of graphite. It's made of carbon atoms joined together in a giant covalent structure, and just like with graphite, each of the carbon atoms is covalently bonded to 3 other carbon atoms. Here's a short video about graphene.
Manchester, birthplace of the Industrial Revolution, home to the father of atomic theory John Dalton and the father of modern computing Alan Turing. From Karl Marx to the contraceptive pill, from the co-op movement to the first hard drive, this city has been a constant source of new ideas. And now, well, Manchester is the centre of a new revolution, another globally significant, game-changing black swan event, and it's called graphene. And it was isolated here in the physics department at the University of Manchester. It's so extraordinary that in 2010, the scientists who made it were awarded the Nobel Prize for Physics. Now, in a story of serendipity and free thinking that rivals any in scientific history, these geniuses did what no one had done before and isolated graphene, creating the first ever man-made material in 2 dimensions. Graphene has almost limitless potential. It's so light and so thin, but it's strong and it's dynamic. The visions, the predictions of sci-fi writers and tech gurus are finally within our grasp. It is a carbon sheet, 1 atom thick, but 200 times stronger than steel. It's the lightest, most conductive man-made material on Earth. It can be used for DNA sequencing at a nanoscopic level. It can be programmed to attach itself to specific cells, like cancer cells, which will revolutionise medicine. It's almost completely impermeable and could be fundamental to the storage and transport of fuels of the future. It stretches, it twists, it rolls to create bendable devices, not just touchscreens, but flexible, transparent components. Graphene devices will be able to carry electricity more efficiently.
A graphene string that is thinner than human hair could support the weight of a grand piano.
It could bring us the revolutionary possibility of electric planes.
In just a few years, we could all be wearing
graphene-laced smart clothing. We could be writing, tattooing, painting electrically conductive reactive inks. The list is endless. In the future, graphene's magnetic properties could bring particle accelerators into our laboratories instead of out on mountain ranges. It could be like having CERN on a desktop. And it is all because of graphene. And it was discovered here at the University of Manchester lab in a city that has always encouraged new ideas. The material of the future in a revolutionary city. It's a free exchange of ideas in a city of innovation. I mean, wow. See, for this city, it's not so much a question of where do we start. It's more about where do we go next?
So why then does graphene conduct electricity? So on the left we have graphite, and the electrons can move backwards and forwards but also up and down. Graphene is 2D, so it's much thinner than graphite, and the electrons can't move up and down, they can only move across. So whilst both of them have delocalized electrons, in graphene the electrons can only move across the structure, and that makes it a really good conductor. Here's a quick question just to summarise what we've looked at so far then. Can you choose the right words from each of the boxes? 1 minute. did you get on then? So the bonds between the atoms in graphene are covalent bonds, and graphene is made of carbon atoms, and in graphene each atom is bonded to 3 other atoms. Carbon nanotubes, you may have heard of these, but what exactly are they? Well, carbon nanotubes are a single layer of graphene that has been rolled into a tube. What predictions then can you make about the properties of a carbon nanotube? So, carbon nanotubes have many useful properties. They have a very, very high tensile strength. They have unique electrical properties and will conduct electricity. And they are good heat conductors. You can have multi-walled nanotubes, and in these several tubes are rotated and slide within each other. And metal atoms can be attached to the outer surface of the tubes. Okay, so we've looked at graphene. Let's now have a look at fullerenes. So carbon can exist in another form. These look like a football, and the first of them, Buckminster fullerene, was discovered in 1985. Buckminster fullerene is a black solid at room temperature, and it does not conduct electricity. It's insoluble in water, but it will dissolve in petrol. And its molecules are strong and hard but elastic like a football. They can be squashed to about 70% of their normal size, but then just like a ball they will bounce back. Would you expect Buckminster fullerene to conduct electricity? I can tell you that it doesn't, so what does that tell you about it? 30 seconds. So, because each of the carbon atoms forms 4 bonds, there are no delocalized electrons. If you remember, to conduct electricity, we need delocalized electrons or free-moving ions. So what we can tell is that even though each of the carbon atoms is only joined to 3 carbon atoms, one of those is a double covalent bond, so that each carbon then actually makes 4 bonds. So all of the electrons are used in bonding. Fullerenes are a really exciting area of science that's currently having lots and lots of research in. Scientists believe there will be many, many uses for fullerenes, and here are some of the ones that they've come up with already. So, they use them to make non-stick slippery coatings for machines. Fullerenes are round like balls, so they will roll, which makes them good for lubricating things. They can be used as cages to hold drug molecules. This is brilliant because it means that the drugs could be delivered directly to the specific site of the body where they're needed. Often when we have drugs such as chemotherapy to treat cancer, then all the cells in the body get affected by it. But if you could target just the cancer cells with the drug molecule, then you could really decrease the number of side effects. We could use them as molecular sieves and trap large particles like viruses, but then allow smaller health particles to pass through. And finally, they could be used as chemical sponges to soak up toxic substances in the body. Right, so to finish then, we have a question that's all about graphene and a real life application of using graphene in mobile phones. There's two parts to this question. So part A would like you to explain, so that says why something is, and use the connective because. Why is graphene strong and why does it conduct electricity? We'd then like you to suggest, and that means put a sensible idea, but doesn't have to be necessarily right or wrong or something that you know, it's just using your general knowledge and common sense and a bit of science. Suggest why a sheet of graphite, which has a large number of carbon layers, would not be suitable for a touch screen. I'm going to give you 5 minutes to do this question. let's self-assess it then. The reason that graphene is so strong is because it has a giant lattice structure, and it has many covalent bonds, and that these covalent bonds take a lot of energy to break. The reason graphene conducts electricity is because it has 3 delocalized electrons, and it has 1 electron per atom. So that means it can conduct electricity, and the electricity will travel through the structure. And then the reason why we wouldn't use graphite for the screen that has many layers is because it would be opaque and we wouldn't be able to see through it, so it wouldn't be much good for a screen. Right, that finishes today's lesson then. On the following slide you'll find notes. If you'd like to make more detailed notes in your book, then pause the video and use the notes appropriately. Thank you.